In the deep-sea environment, even the slightest navigation error can lead to mission failure. However, in situations where GPS signals are unavailable, pressure is immense, and the environment changes rapidly, how can underwater robots like AUVs and ROVs achieve precise navigation? The answer is the M5000 pressure-resistant fiber optic strapdown inertial navigation system. The M5000 is specifically designed for deep-sea unmanned platforms, capable of providing precise data on attitude, heading, speed, and position. It serves as a reliable navigation core for underwater operations. The primary challenge in deep-sea applications is pressure resistance. The M5000 is engineered specifically for harsh underwater environments. It features a pressure resistance of 30 MPa, enabling stable operation at depths of up to 3,000 meters. Its robust housing and multi-seal design effectively protect internal precision components from seawater corrosion and extreme pressure. Within its compact structure, the M5000 integrates a high-performance fiber optic gyroscope and a precision accelerometer, ensuring stable operation even in harsh marine environments. It is far more than just a protective housing. It is a complete deep-sea survival system. The M5000's outstanding performance stems from its powerful sensing core, which integrates a high-precision triaxial fiber optic gyroscope, a quartz flexure accelerometer, and advanced navigation algorithms. The system achieves an attitude accuracy better than 0.02 degrees. In INS-GNSS mode, the heading accuracy is better than 0.2 degrees multiplied by the secant of the latitude. When used in conjunction with a DVL, Doppler velocity log, positional accuracy is better than 0.8% of the distance traveled. Heave measurement accuracy is as high as 5 cm or 5% of the altitude. To verify its performance, the M5000 was tested on a 6 degree of freedom motion platform simulating harsh sea conditions. During dynamic movement, the outputs of the gyroscope and accelerometer remain stable, attitude data responds rapidly to platform motion, and velocity and position outputs remain smooth and continuous. These tests demonstrate that the M5000 can provide reliable navigation information even under harsh marine conditions. High-precision hardware is only part of the solution. The true intelligent core of the M5000 lies in its advanced navigation algorithms. The system employs an enhanced Kalman filtering algorithm to estimate and compensate for various errors, including sensor bias, random walk, and temperature drift. Leveraging multi-sensor fusion technology, the M5000 intelligently integrates data from diverse navigation sources. For surface operations, the INS-GNSS mode provides absolute positioning corrections. For deep water missions, the INS DVL mode serves as the core navigation solution. When connected to an odometer, the INS audio mode offers a cost-effective backup solution. In extreme environments where external signals are unavailable, the M5000 can continue to operate using pure inertial navigation. Its adaptive algorithm can identify anomalous sensor data, mitigate the impact of unreliable measurements, and maintain consistent, stable navigation performance. Each M5000 system is individually calibrated across a wide temperature range of 40 degrees to plus 60 degrees. Temperature compensation parameters are stored internally to ensure consistent accuracy across diverse environments. The system supports navigation solution update rates of up to 200 Hz, providing rapid and precise data output for applications such as AUV underwater exploration, ROV operations, deep-sea mining, and marine scientific research platforms. The M5000 is more than just an inertial sensor. It is a comprehensive deep-sea navigation solution that integrates exceptional pressure resistance, high-precision sensing capabilities, advanced navigation algorithms, and flexible multi-sensor integration. From shallow waters to the deep ocean, and from exploration missions to industrial operations, the M5000 provides reliable navigation support for the next generation of autonomous marine systems. M5000, dive deeper, explore further.